guys, it's Miss Marflag here. You should be extremely excited because today is our last kind of mandatory lesson. This is going to be the last lesson that I'm collecting work for. You're still going to have some videos and you're still going to have to do check-ins our last few days of school, but this is going to be the last kind of grade that's going to be entered into the grade book. Now, our marking period is closing on Friday the 19th, which means I need all of your late work or anything that you've missed before Thursday the 18th at 3 p.m. I will not be accepting 20 assignments or 10 assignments or even 5 or 6 assignments from a student on Thursday at 3 o'clock, okay? You need to be getting your assignments in. They should have been in on time. I'm talking about if you missed one assignment or if you missed 2 assignments, then you can, shoot them to me and I can get them into the grade book. If you are 5 or 6 behind, you can't expect me to grade all of those in and get them in if you give them to me so late and so close to the end of the marking period. So keep that in mind. And today's going to be the last classwork that you're going to have to submit, which is great. And in our last video, we talked about graphing tangent with A and B transformations. We saw that tangent was really similar to the sine and cosine. The only difference was that our period was 180 degrees instead of 360 degrees. And then instead of having that phase shift, what we did was we used that equation to find those asymptotes, negative 90 to positive 90 degrees. And then today we're going to be taking a look at 2 examples with C and D transformations. We're going to do an example with A, B, C, and D, and we're going to do an example with negative. So a lot to do. Let's jump in, and we're going to list out all those variables. So I can see that my A in front of the function is 1, B in front of the function is 1, C is opposite sign, which means it's a positive 45 degrees, and D is a positive 2. Next thing is our period. That's 180 for tangent over B, and B here is 1, so our period is preserved at 180 degrees. We still have those quarters. We didn't have 5 points, but we have 3 points and 2 asymptotes, so we still have 4 distances, which means I take that full period and I divide it by 4. Now 180 divided by 2 is 90, 90 divided by 2 is 45 degrees. And then we use that equation to find those asymptotes. We go negative 90 degrees, everything in parentheses at bx minus c, and then positive 90 degrees. We talked about how this was a compound inequality. We solve a compound inequality by first doing the inverse operation in the middle, and then we do the same thing to both sides. So I'm going to be adding 45 degrees to both sides. And then we're going to see negative 90 plus 45 degrees is negative 45 degrees, and then x, and then 135. So we're going to see that our first asymptote is going to be at negative 45 degrees. That's going to be our starting point, and we're going to go all the way to 135 degrees. This gives us everywhere to plot on the x-axis. Now we need those y-axis, and what we did was the midpoint, which is y equals d. We add the amplitude, and instead of calling it the max, we called it the high point. And we subtract the amplitude and we call it the low point. And then now it's time to graph, so I'm going to lay out that x-axis, and we have, I just need 1 point over here, negative 45, and I need mostly everything above up here. See the 1, 2, and 3. All right, so I got negative 45 degrees. And then my quarters, my distance between each point is 45 degrees. So I add 45, I add 45, I add 45, I add 45. And then I should count here. I got 1, 2, 3, 4, 5. And I could put a little 0 there. 1, 2, 3, 4, 5. And then I got my low point, my midpoint, and my high point. Now we know our first asymptote is here at negative 45 degrees, and we know the shape of our function for tangent when it's a positive tangent. It goes low, mid, high, and then we finish off with an asymptote. So that's the shape of our function: asymptote, low, mid, high, asymptote. So now we get really close to the asymptote, we curve, 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 and then we get really close to the asymptote, and we got ours off to the end there. And then there is our function. And then peeking back at our transformations, we can see it's moved to the right 45 degrees because we usually start at negative 90, and it's moved up 2 because usually this point is through 0. All right, there's the first one. Let's take a look at number 2. Same thing here. Let's list out all those variables. A is 1, B is 1, C is opposite sign, so C is negative 60 degrees, and D is negative 1. My period is 180 divided by B, and B here is 1, so my period is just going to be 180 degrees. And then I know that my quarters is my period divided by 4, and that's going to be 45 degrees. That's my distance between each point or characteristic. And then we set up our asymptotes, negative 90, and then everything on the inside, and then 90. And then we're solving this compound inequality to figure out where those asymptotes are, which means I subtract 60, I subtract 60, subtract 60. And here, same sign, which means that we add and we take that sign. So this is negative 150 degrees, x, and then here we have 30 degrees. And then we can see there are our two asymptotes. And then now it's time to do our midpoint. Is at y equals d. We're going to add our amplitude for our high point. We're going to subtract our amplitude for our low point. So I can see I have everything here sitting below that axis. Now when I look here, most of my points are on the left-hand side. So I need a big chunk here on the left-hand side. And I need my points below that x-axis. So I'm going to put my coordinate plane kind of like this. All right, we're starting at negative 150 degrees. You can use the calculator here. We're going to add, what's our quarter? 45. So we're going to add 45, and I'm going to get negative 105. And then we're going to add 45, and I'm going to get negative 60. And then I'm going to add 45, and I get negative 15. And then I add another 45, and I get a positive 30. And I can see my first asymptote there is at negative 150, and my last one here is at 30. And I got 1, 2, 3, 4, 5 points altogether. Perfect. All right, and then now my high point is at 0, my midpoint is at negative 1, and my low point is at negative 2. We know the shape of our function goes asymptote, low, mid, high, asymptote. So just following the shape of the tangent function, making sure I got arrows off to the end. We get really close to the asymptote. We curve, and get close to the asymptote again. And then there is my beautiful tangent function. All right, so those were two examples with now our C and D. So all we saw here was that our function moved down, or it moved left. It moved down or up, and it moved left or right. And then now we're going to throw in all the transformations to get. Sorry for the cut of the video. I just got a phone call. We just finished up number 2 and we're transitioning to number 3. All right, so now we're going to have all 4 transformations here. I'm still going to list out all those variables. A is 2, B is 3, C is opposite sign, so it's a positive 30, and D is a positive 1. We're going to take that period, and that period we're going to do 180 divided by B, and B here is 3. So we're going to do 180 divided by 3, and that's going to give us 60 degrees. And now we're going to take those quarters, and that's going to be our full period divided by those 4 spaces, and 60 divided by 4 is going to be 15 degrees. And then now we're setting up those asymptotes, and we're going to have bx minus c on the inside between our asymptotes for our parent function, negative 90 and positive 90. All right, so now the goal here is to solve for x in the middle. The first thing I'm going to do is add 30 degrees. That's the first thing you want to do. Add 30 degrees all around. So negative 90 plus 30 is negative 60. And we still have the 3x. We'll take care of that in a minute. And then here we have 120. And then now I can keep solving for x. So this is now a 2-step compound inequality, and we're going to divide by 3. And I'm going to have negative 20 degrees x, and then I'm going to have 40 degrees. And then you can double check here, the total distance from negative 20 to 40 should be your period, and that is 60. Looking good. All right, and then now we can do our midpoint is at y equals d, and d here is 1. Our high point, we're going to add that amplitude, and the amplitude here is 2, so I'm going to add 2 and I get 3. And I'm going to have my low point, and I'm going to subtract amplitude. 1 minus 2 is going to be negative 1. And then now it's time to graph, and I can see that I have 1 point off to the left, so I want to save some room there. And I have 2 points above the line and 1 below the line here. So I'm going to draw my x-axis here. I need the majority of my x-axis above, and I need room for 1 point on the left. All right, let's start on that first asymptote, and we have negative 20 degrees. And I'm going to add my quarter. I'm going to add 15 degrees, and I'm going to get negative 5 degrees. I'm going to add 15 degrees, I get 10 degrees. I'm going to add 15 degrees, I get 25 degrees. I'm going to add 15 degrees, and I get 40 degrees. And then I should see that my starting point is negative 20, and my end point is my other asymptote of 40. And then I have my midpoint at 1. I have my high point at 3, and I have my low point at negative 1. And then we know our shape of the function goes asymptote, low, mid, high, asymptote. And then you can see now that this graph is stretched out a little bit more because we have that A. That A is 2. All right, but it still goes low, mid, high. All right, now for the last one, we're going to see what happens when we have a negative. Thinking about the shape of our tangent function, we usually go, so when y equals tangent x, we have asymptote, you know, low, mid, high, and then there's the shape of our function. Now, thinking about transformations, when you have a negative sign in front of a function, we learned that that meant that we have a reflection over the x-axis. So if I take this and I reflect it over the x-axis, now my function is going to go high, mid, low. So that's the only difference. When you get to that very last step where you're graphing, when you have a negative sign, now you're going to be going high. Sorry again for cutting the video. I ran out of room on the number 4, and I just decided to kind of scrap it and restart again. Okay, so here we are. A is the number in front. Okay, that's going to be 1. B is a half. C is the opposite sign. And D is -2. And then now it's time for that period, and we're going to do 180 divided by B. And B here is 1/2. This is where you can do that keep, change, flip. So I can keep and change to division to multiplication. I can flip 1/2 to 2/1, and I'm going to get 360 degrees. And then now it's time for those quarters, and that's going to be my full period divided by those 4 spaces, and I'm going to see the distance between each point or characteristic is going to be 90 degrees. And then now it's time to set up that inequality for those asymptotes, and we're going to have that bx minus c on the inside. And then we solved a compound inequality in number 3, which means I'm going to start here by solving for x. So I subtract 60 degrees. Subtract 60 degrees. And then here, these are the same signs, so I can add them and take that sign. So I get -150 degrees. And then now I'm solving here for x. So I can divide by 1/2. Or that's the same exact thing as multiplying by 2, as we saw here with the period if you do keep, change, flip. So this is going to be -300 degrees. We're going to be left with that x in the middle and then 60 degrees. And then I can check that total distance from -300 to 60, and I got my period 360 degrees. Looking good. So we do that midpoint, which is y equals d. We add our amplitude for the high point, and then we subtract the amplitude for the low point. And now I can see, looking at my x-axis, most of my points need to be to the left, and I can see, looking at my y-axis, all my points need to be kind of below that x-axis. So this, you know, look at all of your information before you start doing some sketching, okay? So I see that I need like a lot of space over here on the left, and then I need a lot of space below, okay? So that's why I set it up that way. All right, and then now my first asymptote is going to be at -300 degrees. That's my starting point. And I'm going to be adding my quarters. So I'm going to add 90, and we're going to get -210. I'm going to add 90, and I'm going to get -120. I'm going to add 90, and I'm going to get -30, and I'm going to add one more 90, and I'm going to get 60. And then I can see that that's where my last asymptote is. Looking good. All right, and then now we have our high point at -1, our midpoint at -2, and my low point at -3. And we know the shape of our function goes asymptote, right? Asymptote. And usually we go low, mid, high, but I have this little picture here that tells us when there's a negative in front, we go high, mid, low. So I'm going to start off at the high line, I'm going to go mid, I'm going to go low, and then I'm going to have my other asymptote. And then now I can just sketch in that function. So you can see it's reflected over the x-axis. All right, don't be like me. Make sure you go through all of your points. All right, that's it for today. Make sure you email me if you have any questions. This was our last video, yay. We only did 4 examples together, okay, but we did go over, you know, that C and D in the beginning, and then we did some A, B, C, and D, and we finished off with that last one with a negative sign. Once again, get to work on your classwork. This is the last one that we're doing before, you know, all the grades are in. Make it a good one, and email me if you have any questions.